humans have seen supernovae before. Some think that one of these stellar explosions was visible to people on Earth as much as 11,000 years ago. But despite our powerful telescopes and the vivid brightness of these events, it's rare for astronomers to see one all the way through. In March of 2017, however, they got their chance, and what they witnessed answered a 50-year-old question. Telescopes, stat. David Sand, an assistant professor at the University of Arizona, was the first to discover the supernova. Along with the University of California, Davis assistant professor Stefano Valenti, Sand founded the DLT-40 survey, which uses the Prompt telescope in Chile to monitor galaxies less than 120 million light-years away. DLT-40 stands for distance less than 40 megapascs. That's where he saw it, just 55 million light-years away, making it one of the closest supernovae discovered in recent memory. Within minutes, Sand had alerted the Las Cumbres Observatory, which has 18 robotic telescopes positioned throughout the globe to make sure at least one is always on our planet's night side. That way, Sand and his team could keep observing the explosion 24/7. Luckily, Sand caught it in time. This was one of the earliest catches ever, within a day, perhaps even hours, of its explosion, he said in a press release. A question answered. Even luckier, this supernova was a type that had been controversial for decades. It was a Type Ia supernova, a thermonuclear explosion of a white dwarf. White dwarfs are remnants of what used to be stars like our own Sun, and their small stature means they can't explode on their own. Something has to help them along. For more than 50 years, astronomers have debated what that something was. One idea is that it could be a second white dwarf, which creates a cataclysmic explosion when the two bodies spiral in on each other. Another hypothesis is that it's just a normal star. We think what happened here was likely scenario number 2, Sand says. That's because of a strange bump in the light emitted by the supernova. Instead of getting gradually brighter, the explosion emitted a fleeting blue glow that quickly dimmed. The researchers think the white dwarf was sucking matter from a companion star 20 times the size of our Sun, which eventually caused it to explode. That explosion struck the companion star, which heated the supernova material until it glowed blue, something the researchers say couldn't have happened with a second white dwarf. That's huge. We've been looking for this effect, a supernova crashing into its companion star, since it was predicted in 2010, said Griffin Hossenzad, lead author of the paper about the discovery. It's still possible that these kinds of supernovae can result from both kinds of collisions, but the researchers have proven that all it takes is a good telescope network and some quick action to observe them. Next time, maybe we can learn even more.